beginning of the presentation or from the live broadcast chat section. Questions sent through the chat section will be sent to the authors and will be answered by the authors. You can send your questions to the authors about the presentation and the content from the email addresses we shared at the beginning of the presentation or from the live broadcast chat section. Questions sent through the chat section will be sent to the authors and will be answered by the authors.
Sunum ve içerik ile ilgili bildiri yazarlarına sorularınızı sunum başında paylaştığımız e-mail adreslerinden veya canlı yayın sohbet bölümünden iletebilirsiniz. Sohbet bölümünden iletilen sorular yazarlara ulaştırılarak cevaplanması sağlanacaktır.
Now, we will watch the presentation titled Analysis of Barriers Encountered in the Implementation of Big Data Analytics created by İictss Çankaya.
Şimdi, Sibel Yıldız Çankaya tarafından oluşturulmuş büyük veri analitiğinin uygulanmasında karşılaşılan engellerin analizi başlıklı bildirinin sunumunu izleyeceğiz. Buyurun sayın katılımcı.
Herkese merhaba. Benim ismim Sibel Yıldız Çankaya. Bugün büyük veri analitiğinin uygulanmasında karşılaşılan engellerin analizi isimli çalışmamı sunacağım. Öncelikle kısaca büyük veriden bahsetmek istiyorum. Büyük veri mevcut bilgi sistemleri ile algılanması, elde edilmesi, yönetilmesi, depolanması ve analiz edilmesi güç olan veri kümelerini işaret etmektedir. İnternetin bu kadar yaygınlaşması ve hatta nesnelerin bile birbirleriyle iletişim kurabilmesi büyük veri yığınlarının oluşmasına neden olmuştur. Büyük veri altın ve petrole benzer bir şekilde 21. yüzyılın en önemli stratejik kaynağı olarak görülmektedir. Son derece dinamik olan iş ortamı göz önüne alındığında yöneticilerin sezgilerine güvenmek yerine veriye dayalı kararlar almayı tercih etmeleri bu manzarayı karşımıza çıkarıyor. Verilerin önemini anlayan firmalar rekabet avantajı sağlayacak verilerden değer elde etmek için organizasyonel ve teknolojik yeteneklerini geliştirmeye başlamışlardır. Fakat birçok işletme için ve özellikle çoğu zaman yeterli kaynağa sahip olamayan KOBİ'ler için büyük verinin sunabileceği fırsatlardan tam olarak yararlanılmasını güçleştiren bir dizi engel bulunuyor. Bu engelleri aşmak için söz konusu engellerin belirlenmesi ve engeller arasındaki karşılıklı etkileşimlerin ortaya çıkartılması gerekir. Çünkü engeller arasındaki ilişkiler incelendiğinde hangi engel ya da engellere öncelik verilmesi gerektiği belirlenebilecektir. Bu bilgiler ışığında araştırmanın amacı büyük veri analitiğinin uygulanmasının önündeki engelleri belirlemek, bu engeller arasındaki ilişkileri ortaya çıkarmak ve bu engelleri etkileme ve bağımlılık seviyelerine göre gruplandırmaktır. KOBİ'lerde büyük veri analitiğinin uygulanmasını engelleyen faktörleri belirlemek için öncelikle kapsamlı bir literatür araştırması yapılmıştır. Ayrıca bu konuda çalışan akademisyenler ve KOBİ sahipleri, yöneticiler ile görüşmeler gerçekleştirilmiştir. Bunun sonucunda toplam 14 engel tespit edilmiştir. Bu engellere baktığımızda altyapı eksikliği, veri yönetiminin karmaşık, zor olması, kalifiye iş gücü eksikliği, güvenlik ve gizlilikle ilgili endişeler, düşük veri kalitesi ve verilere güven eksikliği, veri yönetiminin zaman alması, yüksek yatırım maliyeti, üst yönetim desteğinin olmaması, strateji veya prosedür eksikliği, veri entegrasyonu ve yönetimi eksikliği, yeni teknolojilerin uygulanmasına ilgi eksikliği, kuruluşlar arasında veri paylaşma politikasının olmaması, faydaları ve getiriler hakkındaki belirsizlik ve son olarak da veri yönetimine uygun bir örgüt kültürünün olmayışıdır. Daha sonraki aşamada bu faktörler yorumlayıcı yapısal modelleme ve mikmek temelli bir yaklaşım kullanılarak analiz edilmiştir. Yorumlayıcı yapısal modelleme ile faktörler arasındaki karşılıklı ilişkiler tespit edilmiş ve mikmek analizi kullanılarak ise listelenen engellerin büyük veri analitiği açısından önemi, etkileme ve bağımlılık seviyelerine göre ortaya konulmuştur. Bu çalışmada oluşturulan anket toplam 15 KOBİ sahibi ya da üst düzey yöneticisine uygulanmıştır ve araştırmada herhangi bir sektörel sınırlamaya gidilmemiştir. İlk olarak yorumlayıcı yapısal model gerçekleştirilmiştir. Kısaca bundan da biraz bahsetmek istiyorum. Yorumlayıcı yapısal modelleme karmaşık bir sistemi birkaç öğeye bölmekte ve daha sonra çok katmanlı hiyerarşik bir model kurarak problemi açıklığa kavuşturmaktadır. KOBİ sahipleri ya da yöneticilerinden oluşan 15 uzmanın görüşlerine göre belirlenen yapısal iç etkileşim matrisi tablo 2'de görülmektedir. Görüldüğü üzere burada bir takım semboller kullanılıyor ve sembolü I faktörü J faktörünü etkilemektedir anlamına gelirken A sembolü J faktörü I faktörünü etkilemektedir. X ise I ve J faktörleri birbirini karşılıklı olarak etkilemektedir. O faktörü ise I ve J faktörü arasında bir ilişki yoktur anlamına gelmektedir. Daha sonra iç etkileşim matrisinde kullanılan bu semboller 1 ve 0 sayısal değerleri ile değiştirilmektedir ve böylelikle başlangıç erişilebilirlik matrisi elde edilmiştir. Erişilebilirlik matrisi oluşturulduktan sonra geçişlilik kuralı kontrol edilmiş ve gerekli düzeltmeler gerçekleştirilerek nihai erişilebilirlik matrisi oluşturulmuştur. Geçişlilik kuralı bu tekniğin temel bir varsayımıdır. Şöyle ifade edebilirim ki eğer x faktörü y ile ilişkili, y faktörü de z ile ilişkili ise geçişlilik kuralı gereği x faktörü z faktörü ile ilişkilidir. Tüm bunlar düşünülerek kontroller yapılmış, gerekli düzeltmeler gerçekleştirilmiş ve nihai erişilebilirlik matrisi oluşturulmuştur. Daha sonraki aşamada seviye bölümleme 5. tabloyu görüyoruz. Bu tablo çok uzun olduğu için tablonun tamamını maalesef yansıtamadım. Sadece 6 faktörün analizlerini görebiliyoruz. Bu seviye bölümlendirmede erişilebilirlik kümesi, öncül küme ve kesişim kümesi bulunuyor. Bunlar nihai erişilebilirlik matrisi kullanılarak elde edilmiştir. Erişilebilirlik kümesi bir faktörün kendisi ve etkilediği diğer faktörlerden oluşuyor. Öncül küme faktörün kendisi ve etkilendiği diğer faktörlerden meydana geliyor. Kesişim kümesi ise bu iki kümede yer alan ortak faktörlerden oluşuyor. Erişilebilirlik kümesi ile kesişim kümelerinin aynı olduğu faktörler hiyerarşinin en üst seviyesine yerleştiriliyor. Bu faktörler yerleştirildikten sonra süreçten çıkartılarak bir sonraki seviyenin faktör ya da faktörleri aynı prosedür tekrarlanarak bulunmaktadır. Bu süreç tüm faktörlerin seviyesi belirlenene kadar devam etmekte ve sonunda bu seviyeler nihai modelin oluşturulmasına yardımcı olmaktadır. Araştırmadaki 14 faktör 9 seviyeye ayrılmıştır. Bunu şu tablodan daha net bir şekilde görebiliriz. Son adımdaki bu tablo 5'teki seviyelendirmelere göre yorumlayıcı yapısal model geliştirilmektedir. Bu modelde belirli bir seviyeye yerleştirilen bir engel kendi altında bulunan engellerden etkilenmektedir. Dolayısıyla herhangi bir engeli ortadan kaldırmak için öncelikle o engelin oluşmasına neden olan engellerin ortadan kaldırılması gerekmektedir. Örneğin strateji veya prosedür eksikliği engelinin ortadan kaldırılabilmesi için öncelikle veri yönetimine uygun bir örgüt kültürünün geliştirilmesi gerekiyor ve aynı zamanda üst yönetimin desteğinin olması gerekiyor. Hiyerarşik yapının temelinde ise yüksek yatırım maliyeti engeli bulunuyor. Bu en önemli, KOBİ'ler için en önemli engel niteliğindedir. KOBİ'lerin öncelikle bu engelin üstesinden gelmesi gerekiyor. Çünkü bu engel diğer engelleri etkileyen en temel engel konumunda. Modelin üst seviyesinde düşük veri kalitesi ve verilere güven eksikliği ile veri yönetiminin zaman alması engelleri yer alıyor. Bu engeller hiyerarşik olarak daha alt seviyelerde yer alan engellerden etkilenmektedirler. Yani işletmeler bu engelleri ortadan kaldırmak ya da iyileştirmek istiyorlarsa öncelikle hiyerarşinin altında kalan engelleri iyileştirmeleri gerekmektedir. Yani kısacası KOBİ'lerin öncelikle hiyerarşinin altındaki engellere odaklanmaları gerekiyor. Yani yüksek yatırım maliyeti, faydaları ve getirileri hakkındaki belirsizlik, kalifiye iş gücü, uygun bir örgüt kültürünün oluşturulması, üst yönetim desteğinin olmaması gibi noktalara odaklanılması gerekiyor. Diğer analizimiz Micmac analizi. Micmac analizi ile sistemi yönlendiren en yüksek güce sahip değişken ya da değişkenler ortaya çıkartılabilir. Bu analiz nihai erişilebilirlik matrisinden yola çıkarak her bir faktörün etkileme ve bağımlılık güçleri temel alınarak yapılmaktadır. Şöyle baktığımızda nihai erişilebilirlik matrisine her bir faktör için etkileme seviyeleri ve en altta da bağımlılık seviyeleri hesaplanmıştır. Altyapı eksikliği için etkileme seviyesinin 6 olduğunu görüyoruz. Yani kendisi ve etkilediği diğer değişkenlerin sayısı. Bağımlılık ise altyapı eksikliği için baktığımızda 9. Yani kendisi ve etkilendiği diğer değişkenlerin sayısı. Dolayısıyla bu ilgili verileri tablodan, grafikte yerine yerleştirerek 4 bölge elde ediyoruz. Birinci bölge nötr değişkenler bulunuyor bu bölgede. Düşük etkileme seviyesi ve düşük bağımlılık seviyesine sahiptir. Bu değişkenler sistemin geleceğini çok fazla etkilememektedir ve sistemden göreceli olarak kopukturlar. Güvenlik ve gizlilikle ilgili endişeler, yani F24 bu bölgede yer alıyor. Bu faktördeki değişimler diğer faktörler üzerinde fazla etki yaratmıyor. Benzer şekilde bu faktör diğer faktörlerden de pek fazla etkilenmiyor. Kısacası bu engel düşük önceliğe sahiptir ve kendi başına büyük veri analitiğini pek fazla etkilememektedir. Bu bölgede sadece bir engelin bulunması araştırma için doğru engellerin seçildiğinin de bir kanıtı niteliğindedir aslında. İkinci bölge bağımlı değişkenler. Bu değişkenler düşük etkileme seviyesine sahip olmakla birlikte yüksek bağımlılık seviyesine sahiptirler. Bu değişkenler 3. ve 4. bölgede yer alan değişkenlerden etkilenirler. Bu kategorideki değişkenler sistemdeki etkileşimlerin ve ilişkilerin sonuçlarını yansıtmaktadırlar. Bu bölgede altyapı eksikliği, F1 düşük veri kalitesi ve verilere güven eksikliği F5, veri yönetiminin zaman alması F6, veri entegrasyonu ve yönetim eksikliği F10 ve kuruluşlar arasında veri paylaşma politikasının olmaması F12 engelleri bulunmaktadır. Bu engelleri iyileştirmek için öncelikle 3. ve 4. bölgede yer alan engellerin iyileştirilmesi gerekmektedir. Üçüncü bölgeye geldiğimizde bağlantılı faktörler, bunlar hem yüksek bağımlılık seviyesine hem de yüksek etkileme seviyesine sahiptirler. Bu bölgede bulunan değişkenler üzerinde herhangi bir değişiklik diğer değişkenleri de etkileyecektir. Diğer değişkenlerde meydana gelen değişiklikler ise bu değişkenlerin etkilerini arttıracak veya azaltacaktır. Araştırmada üçüncü bölgede veri yönetiminin karmaşık zor olması F2, üst yönetim desteğinin olmaması F8, strateji veya prosedür eksikliği F9 ve yeni teknolojinin uygulanmasına ilgi eksikliği F11 engelleri yer almaktadır. Bu kategoride yer alan faktörler istikrarsızdır ve dolayısıyla çok dikkatli bir analiz gerektirmektedirler. Uygulayıcılar uygulamanın her aşamasında bu faktörleri sürekli gözlemlemelidirler. Dördüncü bölgeye geldiğimizde bağımsız değişkenler ya da etkileyen değişkenler diyoruz. Yüksek etki seviyesi ve düşük bağımlılık seviyesine sahiptirler. Bu değişkenler sistemin geri kalanını etkiledikleri için önemli faktörler olarak görülmektedirler. Bu kategoride yer alan değişkenler kalifiye iş gücü eksikliği F3, yüksek yatırım maliyeti F7, faydaları ve getirileri hakkındaki belirsizlik F13 ve veri yönetimine uygun bir örgüt kültürünün olmayışı F14'tür. Bu değişkenlerin varlığı diğer tüm değişkenleri de etkilediği için büyük veri analitiği kurulurken bu faktörlere öncelik verilmesi gerekmektedir. Yani bu engeller KOBİ'ler öncelikle üzerinde durması gereken, KOBİ'lerin öncelikle üzerinde durması gereken engellerdir. Evet, beni dinlediğiniz için teşekkür ederim.
You can send your questions to the authors about the presentation and the content from the email addresses we shared at the beginning of the presentation or from the live broadcast chat section. Questions sent through the chat section will be sent to the authors and will be answered by the authors.
Sunum ve içerik ile ilgili bildiri yazarlarına sorularınızı sunum başında paylaştığımız e-mail adreslerinden veya canlı yayın sohbet bölümünden iletebilirsiniz. Sohbet bölümünden iletilen sorular yazarlara ulaştırılarak cevaplanması sağlanacaktır.
Now, we will watch the presentation titled Improving Web Page Classification with Two Novel Approaches on Semi-Supervised Learning created by Havva S. Ünal and Selma A. Özel.
Şimdi, Havva Esin Ünal ve Selma Ayşe Özel tarafından oluşturulmuş yarı denetimli öğrenmede iki yeni yaklaşımla web sayfası sınıflandırmasını iyileştirme başlıklı bildirinin sunumunu izleyeceğiz. Buyurun sayın katılımcı.
Hello to everyone. You are all welcome to our presentation titled as Improving Web Page Classification with Two Novel Approaches on Semi-Supervised Learning. So, first of all, what we are going to cover. Throughout the presentation, firstly, I'm going to make a brief introduction to the topic. Then I will present you the materials and methods that we have used in our study. After that, I will give you the results and discussions about them. And then I'm going to end my presentation with a summary of our study and some future works that we are planning. So, as all we know, there are plenty of information which have not been discovered yet. This information mostly exists in the raw form of data sources, and as the volume of data increases, the understanding of them by the people decreases. Data mining is a particular step in the overall process of discovering useful information from these data sources. There are different kinds of mining tasks to extract the desired information, such as supervised learning, in which case all the data is labeled, or unsupervised learning, in which case the labels of the training data are unknown, and semi-supervised learning, in which case there are limited number of labeled data and mass amount of unlabeled data. In this study, semi-supervised learning is studied, which only needs a small amount of labeled data and a huge amount of unlabeled data. In this type of learning, by the help of limited information, of course, the hidden information inside the unlabeled data sources can be used to build better classifiers than fully supervised learning, additionally at a reduced labeling cost, of course. Semi-supervised learning can be both used for classification and clustering. In this study, semi-supervised classification is studied. Now I want to give information about the materials and methods that we have used in this study. In this study, 9 binary classification datasets are preferred from the publicly available WebKB, bank search, and the manually collected conference dataset. The conference dataset consists of the computer science-related conferences homepages. This dataset is manually collected by us and used in our previous studies. The names of the conferences in the dataset are obtained from the DBLP Computer Science Bibliography, and then these names are queried using the Google search engine. The conference's homepages in the query results are labeled as positive documents. In addition, the web pages that include similar information with the conference's homepages but are irrelevant are labeled as negative documents. Then, all the positive and negative documents are randomly distributed among the training and testing data. The conference dataset contains 2,369 web pages in total. From them, 824 are randomly distributed as positive and 1,545 negative documents exist. From these, 75% of the pages belonging to the training data and 25% of it belongs to the testing data as seen in the table. The WebKB dataset was prepared by the WebKB project at Carnegie Mellon University. The datasets consist of 8,282 web pages collected from Cornell, Texas, Washington, and Wisconsin universities, and the pages are classified into 7 categories. These categories are named as student, faculty, staff, department, course, project, and other. Some parts of the WebKB dataset are used in our study, like student, faculty, course, and project categories are used because these categories have more instances than the remaining ones. For each category, a binary classification dataset is generated. Therefore, course, student, faculty, and project datasets are obtained. For each dataset, the other category of the WebKB dataset is used as negative class instances, and the train and test numbers can be seen again from the table for each of these datasets. The bank search dataset consists of 11,000 web documents from 11 equally sized categories. Each of the category contains 1,000 web pages. From these 11 categories, we have chosen 4 of them: commercial banks, programming, biology, and motorsport. Negative pages are selected randomly from the rest of the categories. So as you can see in the table, each data set consists of 4,500 documents in total. As stated in many studies, the pre-processing step affects the classification process in a positive manner. All the documents in the datasets are HTML documents composed of HTML text and content. So, in the first step of pre-processing, the documents are randomly selected to form the training set, and then the remaining documents are taken as the test set. The number of the documents were given in the previous slide. The documents in the training sets are then randomly separated as labeled and unlabeled sets. After that, each document is scanned for some special text like title, heading text, link text, href, italic text, bold text, and p text, and list text are used. For each document, stop words, numeric values, and punctuation marks are removed. Then, the remaining terms are lowercase and stamped according to the Potter's stemming algorithm. Then, for each document, a text document is constructed as seen in the picture. The form text document has a structure, the tag name in the beginning, and after that, all the words that are seen in between these tags separated by space characters, as you can see from the example here. In my doctoral study, I have examined 8 different feature extraction methods, and then from them, I showed that these feature extraction algorithms are the best 3 performance among them. So, we use these feature extraction algorithms in the SSL methods. The first one is tagged terms. It has been demonstrated in many studies that using the information derived from HTML text can increase the classifier's accuracy. So the features are only extracted from a set of logical and physical HTML text like title, headings, italic, and bold text. We use each stem term with its associated HTML tag as a feature. Therefore, the identical terms in different tags are deemed as different features. This kind of feature extraction algorithm is named as the tagged terms feature extraction algorithm in our previous studies. I'm going to give the detailed algorithm in the upcoming slide. Bag of words, the second feature extraction algorithm. The textual content in the web page is the most popular feature pool that is preferred. So in this method, all the HTML tags are removed and then the remaining pure text is used. And the last one is anchor feature extraction method. In this method, all of the terms that belong to just link tag, which is a href tag, are taken as a feature. So let's give a little bit detailed information about the tagged terms feature extraction algorithm. In tagged term feature extraction method, each unique stemmed term and its corresponding HTML tag are combined to form a feature for the document. As an example, stemmed term student between the title heading 1 and paragraph text from title form the title student, heading 1 student, and text student features for the document. Although we have the same word, STEM student, as their positions in the web page are different, we have 3 different features for the document. Therefore, apart from using each tag group alone, all the terms from all the tag groups are used. So a term can be in the feature list several times because every term is used with its corresponding tag. The second used feature extraction algorithm was bag of words. Here you can see the algorithm of it. As can be seen, different from the previous algorithm, position of the stemmed term is not important. Each unique word stem occurred in the web page is taken as a feature. So, after the feature extraction, we applied the feature selection process. Feature selection is an important process for increasing the classification accuracy and the classifier speed, of course. For this reason, the final version of the feature set to be used in classifications was determined after the feature selection stage. According to a study which is done by Salton and his friends, the most useful terms are the ones having document frequencies between 1% and 10%, due to the fact that low document frequency terms are generally the misspelled ones, and high document frequency terms are often stop words. For this reason, the features having a document frequency of less than 2% are removed for each dataset to eliminate the misspelled terms. This threshold is determined, of course, experimentally. After the selection stage, the document vectors of train and test sets are constructed. Each document vector consists of the words in the feature set plus the numeric weight value assigned to the word. For weighting each feature for a document, TF times IDF value, which is the multiplication of the number of occurrences of the feature in the document, which is TF, with inverse document frequency, which is given as IDF, of the feature is applied. Inverse document frequency is the logarithm of number of documents in the collection divided by the number of documents that contain the given feature. Therefore, IDF gives more weight to features that are not very frequent among the documents in the whole collection, but are discriminative. Then we converted these document vectors into R format, which is the format determined by Weka software that will be used for classification. For all of these stages, Java programming language was used. Now let's talk about the classifiers that we have used. We have used 5 different classifiers in different parts of the study, which are multinomial naive Bayes, decision tree, k-nearest neighbor, rule-based, and support vector machine. Applications of these classifiers in WCA software can also be seen in this table. In my doctoral study again, I compared these classifiers and decided to use support vector machine, decision tree, and naive Bayes multinomial classifiers inside the SSL algorithms. After labeling is completed with the SSL algorithms, the performance of these semi-supervised learning algorithms are evaluated by using all of these 5 classifiers to get classifier-independent results, of course. There are many popular methods for semi-supervised classification, but we have chosen co-training and iterative cross-training methods from them, because the co-training is a method that is used commonly for comparisons in semi-supervised learning experiments, and the idea behind the iterative cross-training method is close to the proposed ones. So as a result, we implemented these 2 methods in addition to our proposed methods, incremental serial training and incremental parallel training with cross-validation. So starting with co-training, it is a very popular approach used in semi-supervised learning, which was first introduced in 1998. From the different versions of this algorithm has been used in many studies. The basic idea in the co-training algorithm is to use different views for representing the dataset. The training examples of a view are augmented by exploiting the classifier of the other view. It assumes that the views are conditionally independent given the class label, which is known as independence assumption, and each view alone can make good classifications with enough labeled data, which is known as compatibility assumption. As seen from this figure, we are enlarging the labeled set by training 2 different classifiers, which uses 2 different views, and at last adding the newly labeled ones to the label set. In the co-training algorithm, a learning method, which is like multinomial naive Bayes, is trained on 2 different views, or we can say them as feature sets. Therefore, there are 2 classifiers present. In the first step of the algorithm, a smaller pool of unlabeled examples are chosen because it is shown by different researchers that using a smaller pool gives better results than using all of the unlabeled data. Of course, this smaller pool is chosen randomly. The algorithm continues until there is not enough examples in the unlabeled set or a given k number of iterations is reached. In each loop, the chosen classifier is trained twice by using 2 conditionally independent feature sets, as given in this algorithm, x1 view and x2 view of the examples x of the label set, and as a result, classifiers C1 and C2 are formed. Then the label set is enlarged in each loop by using these classifiers. So now the parameters of co-training. In order to make fair comparisons with the proposed semi-supervised learning methods, similar Bayes learning and feature extraction methods are used. As a total, 30 experiments are applied for each data set, in which only the documents in the initial label set is changed, which is randomly chosen from the training set of data sets. These experiments are made in order to give more accurate results, so that the results do not depend on the labeled documents chosen initially. The number of samples in the initial label set are decided by calculating the 5% of the positive and negative documents in the smaller pool of unlabeled set. This percentage is chosen according to the original article of iterative cross-training, the second algorithm that we will compare with our proposed ones. The number of iterations in all the data sets is determined as experimentally, and this value is set to 30. The values of initial label set and unlabeled subset numbers, the chosen positive and negative example numbers that are used in the experiments, are given in this table. The positive and negative numbers given here are chosen according to the ratio between the positive and the negative documents in each data set. So the ratio is preserved. So our second approach that we will compare with our proposed ones is the iterative cross-training algorithm. Iterative cross-training algorithm combines two classifiers, and these classifiers iteratively train each other. The main difference from the co-training algorithm is that the label set and unlabeled sets of these two classifiers are distinct in iterative cross-training. The unlabeled data set is duplicated to be used for the first and the second classifiers separately. In each iteration, the classifier labels its unlabeled data for the other classifier, as shown in this figure. In this algorithm, the first classifier uses the domain knowledge, or if no domain knowledge available, a small set of labeled data is used. Then, to estimate labels of one of the unlabeled example sets for the second. The second one uses only these labeled examples to learn its model. Then it uses this model to label the other set of unlabeled examples for the first classifier. This training process is repeated until the number of iterations exceeds a predefined value or parameter set for the first classifier doesn't change. The algorithm has two labeling models, which are named as batch and incremental. At incremental mode, at each iteration, a small number of examples are labeled and added to the other classifier's label set. And in the batch mode, all the examples are labeled at each iteration. The incremental mode found more robust than the batch mode. Therefore, for this study, we used incremental iterative cross-training algorithm. So these are the parameters that are used in Iictss. Again, as you will see, in order to make fair comparisons with the proposed semi-supervised learning methods, similar based learning methods and feature extraction methods are used. So as a classifier, one, we use support vector machine classifier libsvm. As a second classifier, we use J48 with bag of words feature extraction method. And with the first classifier, we use tagged terms feature extraction algorithm. The number of iterations, the K number, is chosen as 30 for all data sets. And 5% of the training set is randomly chosen as initial label set, as in the case of co-training. And experiments repeated for 30 randomly chosen initial sets. And the initial label set number, unlabeled set number, and positive and negative document numbers chosen at each iteration are given in this table. Now, let us talk about the proposed algorithms of the study. First, starting with incremental serial training, which is the first proposed approach in the study, combines three classifiers and uses unlabeled examples serially to form a label set. Each of the classifier uses a different view of the data set. So, from this point, this is a multi-view method. The classifiers iteratively train each other for improving the performance of every classifier. So let us now see the algorithm. As it can be seen from the algorithm, at the beginning, classifier 1 is trained with a given small label set, which will be called as L, as given here. After that, the most confident, which is decided according to the classification probabilities, of course, P positive and N negative examples from the given unlabeled set are chosen by using classifier 1 and then added to the label set. Then with this new label set, classifier 2 is trained, and again P positive and N negative examples are chosen and added to the label set. In the same manner, classifier 3 is trained with the enlarged set, and P positive and N negative examples again are chosen and added to the label set. So the procedure continues in this way until there are no more unlabeled examples left in the unlabeled set, or the number of iterations exceeds a predefined value. As can be seen from the algorithm, the classifiers are working serially and incrementing the labeled set at each round. For this purpose, we named it as incremental serial training. These are the parameters that are used in Iictss algorithm. Again, with the same based learning methods, and the feature extraction methods are used in Iictss also. As classifier 1, we use the libsvm classifier with tagged terms feature extraction method. As classifier 2, we use J48 with bag of birds. And as classifier 3, we use NAIO-based multinomial as with the anchor feature extraction method. The number of iterations are again 30 for all data sets. The initial label set is chosen from the training set. 5% of training set is randomly chosen as an initial label set. And experiments repeated for 30 randomly chosen initial sets, of course. And the other parameters are identical as given in the Iictss method. Now the second proposed approach, incremental parallel training with cross-validation. We will call it as IPTCV. It uses three classifiers again, similar to the previous proposed one, classifier 1, classifier 2, and the validation classifier. In this case, as you can see, one of the classifiers is used when needed for cross-validation, so we named it as validation classifier. The features are extracted by using different feature extraction methods for each classifier. So this is a multi-view method too, as the other proposed one. This naming convention is used because the classifiers work at the same time, in this case, at each round, and increment the labeled set in a certain rule that we are going to give in the next slide. So in this proposed algorithm, at the beginning, all of the classifiers are trained with a given small label set L. All the classifiers label the examples of the unlabeled set U and form their candidate lists for the positive and negative labeled examples simultaneously. The candidate lists of classifier 1 and classifier 2 are compared and checked for identical labels. Every example satisfying this condition is added to the validated label list. Otherwise, if an example doesn't satisfy this condition, the system checks the list of validation classifiers and labels the example according to it and edits it to the validated labeled list for this check. In each iteration, a given number of most confident positive, at most 2 P positive documents and negative, at most again 2n negative documents are chosen from this validated labeled list and added to the labeled set L. So we are incrementing, we are making incremental labeling. After they are added, these examples are of course removed from the unlabeled sets. Then this new labeled set is used to train all of the classifiers again. The procedure continues until there are no more unlabeled examples left in the unlabeled set, or the number of iterations exceeds a predefined value. So, what are the parameters of Iictss? These are the parameters that are used in our algorithm. As we said at the beginning, similar based learning methods and the feature extraction methods are used in all semi-supervised learning algorithms. So as classifier 1 in Iictss, we have chosen J48 with bag of words feature extraction. For classifier 2, we have chosen naive bayes multinomial with anchor feature extraction method. And as a validation classifier, since it is found in our previous studies, the best classifier and best feature extraction methods, LIP SVM and tagged terms feature extraction methods is used as a validation classifier, and the number of iterations is similar to the other semi-supervised learning methods is chosen as 30 for all data sets. Randomly chosen initial label set number is again 5% of the training set, and experiments are all repeated for 30 randomly chosen initial label sets. The other parameters, again, are identical with the ICT method. So, in the experiments of the study, the F measure, which is commonly used as a metric, is employed for performance evaluation. The F measure is a harmonic mean of the precision and the recall of the test, and it is defined as given in this equation here. Okay? Sorry. In general, precision in the measure of exactness, the proportion of documents labeled as positive are actually such, and recall is the measure of completeness, the percentage of positive documents that are labeled correctly. In the F measure metric used in the study, precision and recall are combined and are given equal weights. So now the results and discussions that we have found about the semi-supervised learning method, about the comparison of semi-supervised learning methods. In the study, we compared two known methods, co-training and ICT, with the proposed two methods by using WebKV, bank search, and conference data sets. We recoded these two popular methods and give equal conditions with the proposed ones for fair comparisons. After labeling all the documents in each data set, in order to compare the performance of semi-supervised learning algorithms, we obtained 4,800 values for each data set, and then analyze these results statistically. By doing this much trials, we aim to obtain more accurate results that are not dependent on any conditions such as feature selection method, starting set, or classifier. We obtained this number, 4,800 different F measure values, by using 30 randomly chosen initial sets, 8 feature extraction methods, 5 classifiers, and of course 4 different SSL methods. And so, as seen from this figure, we obtained 4,800 values for each data set. And then, of course, we statistically compared them. Now, let us look at the results that we gained of each data set separately. First, we will talk about the conference data set that we have constructed. For the conference data set, disregarding, of course, the feature extraction methods and classifiers, the means of all the F-measure values for semi-supervised learning methods, co-training, ICT, ISD, and IPTCV are given in this table. The p-value given in the table indicates that there are significant differences among the semi-supervised learning methods for the conference data set. As a result of pairwise comparisons between the methods, one can conclude that IPTCV, which is proposed by us, performs better than co-training, ICT, and the second proposed one, IST methods. In addition, the second proposed method, IST, is better than ICT and co-training methods, as you can see from this table and from this figure. Also, when you look at the graphic given here, we can say that the minimum estimated F-measure value for IPTCV is higher than the maximum estimated F-measure values of other methods, which are co-training and ICT. Now, a popular group of data sets which are used in many studies in this field, WebKB results. Again, disregarding feature extraction methods and classifiers, the mean of all the F-measure values for semi-supervised learning methods for each WebKB dataset is given in this table. The p-value, again, given in the table indicates that there are significant differences among the SSL methods for the WebKB datasets too, as in the case of conference. For the course and faculty datasets, you can see from the table that IPTCV and ISD methods performs better than co-training and also ICT methods. As a result of pairwise comparisons between the methods for the course dataset, first of all, IPTCV performs better than co-training, ICT and IST methods. IST, the second proposed one, and ICT are statistically equal to each other. For the faculty dataset, IPCTV performs again better than ICT and IST methods, but statistically equal to the co-training method. And the second proposed method, IST, is statistically equal to ICT and co-training methods. For the project dataset, IPTCV is statistically equal to ICT methods, but better than co-training and IST methods. On the other hand, the second proposed method is statistically equal to co-training method, and unfortunately, they give the lowest F-measure value for the project dataset. For the student datasets, IPT, IST, and ICT, they are all statistically equal to each other. They are all better than the co-training method. Our last group of data sets that we used in our examples was bank search data sets. As we stated before, disregarding feature extraction methods and classifiers, the means of all the F-measure values for semi-supervised learning methods for each bank search dataset is given in this table. Again, the p-value indicates that there are significant differences among the SSL methods for this data set. When we made pairwise comparisons between the methods, we saw for commercial bank and motorsport, these two data sets, IPTCV, one of the proposed methods in the study, performs better than co-training. ICT and ISD methods, the second proposed one. And for the biology and the programming data sets, the other two ones here, IPTCV, the proposed methods in this study, and ISD methods are statistically equal to each other. These methods are better than the ISD method, the second proposed one. On the other hand, co-training method obtains the lowest F-measure value for these two data sets. Now, in this slide, disregarding feature extraction methods, classifiers, and also the data sets, the means of all the F-measure values for semi-supervised learning methods are given in this table here. So, as a result of pairwise comparisons between the methods, as seen in the second table, okay, we have done the pairwise comparisons and showed it in this table. IPTCV method, which is proposed in the study, performs better than co-training, ICT, and ISD methods for all the data sets, okay? On the other hand, the second proposed one, ISD and ICT, iterative cross-training, are statistically equal to each other. And you can clearly see that the co-training methods obtains the lowest F-measure value as given here. As we know, supervised learning methods will be able to classify with high classification performance in case of sufficiently large labeled training data set for classification. In our experiments, we also made the study and found 0.85 as an F-measure value. However, as you can see in this table, however, when the knowledge is not sufficient, which means that, as in our case, we have just chosen 5% of the positive and negative documents in the training test set and used as the initial label set, the mean F-measure value of supervised learning experiments decreases. As you can see, it is decreased to 0.77 according to the experiments we handled. In this case, it is seen that the classification performance, okay, when we use the 5% of the positive and negative documents in the training set, in which case the labeled document number is small, the classification performance can be increased by using the semi-supervised learning methods, which uses the hidden information in the unlabeled dataset. Especially the IPTCV approach, which is proposed in the study, has shown that it can be a good alternative with a mean F-measure value of 0.80, as given here. Don't forget, the results that are presented in the table are obtained by taking the mean F-measure values of all the experiments on WebKB, bank search, and conference data sets. When we look to the results according to the data sets, we have also seen that the results of the proposed methods, IPTCV and ISD, are better than the supervised learning results by using both larger and smaller number of label sets for two of the data sets, namely faculty and project, as given here, okay? Also, in 7 of the data sets, which are shown as underlined, biology, commercial banks, motorsport, faculty, project, student, and conference data sets, the proposed method IPTCV has larger mean F-measure value than the supervised learning method that use same amount of label sets as the semi-supervised learning methods. So, as a summary, we can say that, first of all, the performance of the two proposed methods are very high, especially the incremental parallel training with cross-validation method has the highest classification performance among all other methods. When examined for each data set, it is observed that the IPT-CV obtained the highest F-measure value in 5 out of 9 data sets, which are course, faculty, biology, commercial banks, motorsport, and conference data sets. In the faculty data set, IPT-CV and co-training obtained statistically equal F-measure values. In the remaining 3 data sets, IPT-CV and IST obtained statistically equal F-measure values, which are project, student, and programming. Sorry, from 6 of the 9 data sets, we have the highest F-measure value. Although the number of initial positive documents in each data set is different, the proposed method's classification performance are not negatively influenced. Moreover, in most of the data sets that started with smaller size initial positive labeled documents, in which case the size is smaller than 40, IPT-CV method achieved the highest classification performance. Therefore, it is recommended that the IPT-CV method be used in all data sets and especially that contain smaller initial label sets in case of less information, and are difficult to classify, like which are more complex data sets. Another conclusion is IPT-CV method makes less error in labeling the documents as positive and negative due to the discrepancy resolving system inside the method. By adding a third classifier, the validation classifier, in IPT-CV, there is a chance to correct the label in case of discrepancy between the other 2 classifiers. It is also experienced that when the knowledge is not sufficient, just only the 5% of the positive and negative documents in training set are used at initial label set, the classification performance can be increased by using the semi-supervised learning methods. Especially, of course, the IPT-CV approach proposed in the study has shown that it can be a better alternative than other semi-supervised methods examined in this study. And now a few words for the future work. Firstly, a weighting schema can be added to the classifiers of the proposed method so that the effect of a classifier can be increased or decreased inside the methods. Also, the classifiers that are used in the IPT-CV and IST methods can be changed. Classifier types can significantly change the classification success of methods in order to make a general comment for each data set. The same classifiers are used for the study, but according to the structure of a data set, more appropriate classifier types can be chosen. Another study can be made on the choice of number of iterations in the proposed methods. According to the results, it can be said that for the IPT-CV method, 30 is a good choice for the iteration number, but on the other hand, it may not be sufficient for the IST method. In addition, and as an additional study on the choice of iteration number can be done. So this is the end of my presentation. Thank you for your patience and thank you for listening.
You can send your questions to the authors about the presentation and the content from the email addresses we shared at the beginning of the presentation or from the live broadcast chat section. Questions sent through the chat section will be sent to the authors and will be answered by the authors.
Sunum ve içerik ile ilgili bildiri yazarlarına sorularınızı sunum başında paylaştığımız e-mail adreslerinden veya canlı yayın sohbet bölümünden iletebilirsiniz. Sohbet bölümünden iletilen sorular yazarlara ulaştırılarak cevaplanması sağlanacaktır.
Now, we will watch the presentation titled The Combined Evaluation of Biometric Data Collection Technique and Sensory Analysis of Food Products, a new proposal for interdisciplinary field studies created by Mustafa Seçkin, Alican Taşkıoğlu and Behiç Alpaytekin.
Şimdi, Mustafa Seçkin Aydın, Alican Taşçıoğlu ve Behiç Alpaytekin tarafından oluşturulmuş gıda ürünlerinin biyometrik veri toplama tekniği ve duyusal analizinin kombine değerlendirilmesi, disiplinler arası saha çalışmaları için yeni bir öneri başlıklı bildirinin sunumunu izleyeceğiz. Buyurun sayın katılımcı.
Herkese merhaba. Bir araştırmamızı sunmak için burada bulunuyorum. Araştırma başlığımız, biyometrik veri toplama tekniği ile gıda ürünlerinin duyusal analizinin birlikte değerlendirilmesi, disiplinler arası saha araştırmaları için yeni bir öneri. Şimdi ilk olarak duyusal değerlendirme, duyusal analiz nedir? Bundan başlamak istiyorum. Duyusal analiz, gıdaların çeşitli karakteristiklerine görme, koklama, tatma, dokunma ve işitme duyularının tepkilerini oluşturan, ölçen, analizleyen ve yorumlayan bir disiplin olarak tanımlandığını görmekteyiz. Bir gıda maddesinin tüketici tarafından ilk izlenimini temel duygusal özellikler olan görünüş, doku ve lezzetin oluşturduğunu söyleyebiliriz. Peki gıdaların duyusal analizinde hangi yaklaşım biçimleri yer alıyor? Bunlar puanlama ölçeği, kategori ölçeği, grafik değer ölçekleri ve hedonik ölçekler olmak üzere 4 tane. Ve araştırmacıların istenen katılımcılardan koku, lezzet, tekstür ve görünüş gibi karakteristik özellikleri gıdaların incelenmesi isteniyor ve katılımcılardan da duyusal değerlendirmeleri yapmaları bekleniyor. Duyusal analizlerde bazı hatalar yaşanabiliyor. Bunlar fizyolojik faktörler ve psikolojik faktörler olarak iki kategoride değerlendiriliyor. Fizyolojik faktörler adaptasyon, geliştirme veya bastırma. Psikolojik faktörler ise beklenti hatası, alışma, uyaran, mantıksal hata, halo etkisi, numunelerin sunulma sırası, karşılıklı öneri, motivasyon eksikliği, kaprisliğe karşı çekingenlik ve kötü fiziksel durum. Örnek verecek olursak numunelerin sunulma sırası burada önem arz ediyor. Genellikle panelistler ilk numuneye karşı daha olumlu duygular besliyor ve bu şekilde bir yanlılık söz konusu meydana gelebiliyor. Dolayısıyla numunelerin sırasını değiştirmek burada yaşanan hataları engellemede önemli oluyor. Biyometrik yöntemlere baktığımızda diğer bir ismiyle şu an güncel literatürdeki ismiyle biyometrik veri hasadı olarak geçiyor. Biyometrik veri hasadının tanımına baktığımızda insanların belli bir uyarana karşı verdiği psikofizyolojik tepkilerden oluşan verilerin biyometrik arayışlar ile toplanması ve bu verilerin anket, mülakat gibi geleneksel metotlarla desteklenmesi sonucu olgunlaşmış karma veri elde edilmesi süreçlerini kapsayan bir teknik olduğunu görüyoruz. Burada biyometrik veri araçlarla kullanılan diğer geleneksel yöntemler, anket, mülakat gibi aslında bizim e, gıdaların duyusal analizde de kullandığımız ölçekler de buraya dahil oluyor. Bu ölçekler sonucu elde ettiğimiz niceliksel verileri biyometrik veri teknikleriyle birleştirdiğimizde karma bir yöntem ortaya çıkıyor. Biyometrik yöntemlerin çeşitlerine baktığımızda ilk olarak elektrodermal tepkisinden bahsedeceğim. Diğer bir ismiyle GSR, Galvanic Skin Response olarak gerçekleşiyor. GSR, cildin elektriksel özelliklerine bir değişiklik olarak tanımlanıyor. Bu tepki avuç içlerinden veya ayak tabanlarına elde edilebiliyor. Sağdaki fotoğrafta örnekte gördüğünüzde bireyin elinden elde edilen elektrik iletkenliği bu şekilde ortaya çıkıyor. Peki ne yapıyoruz biz buradan elde ettiğimiz veriyle? Bireyin duygusal uyarılmada olumlu veya olumsuz değerlendirip değerlendirmediğini, yani uyarana karşı ver tepkinin olumlu veya olumsuz olmadığını görüyoruz. Aynı zamanda bu deri iletkenliği sakin, heyecanlı gibi değişen duygusal uyarılarda sistematik olarak değiştiği de daha önceden tespit edilmiştir. Diğer bir biyometrik yöntemde sıklıkla kullanılan göz takip tekniği. Bu teknik kişilerin belli bir zaman aralığında belirli noktalar arasında gerçekleşen göz hareketlerinin takip edilebilmesi adına kullanılan bilimsel metot. Gözü bir noktaya sabitlemek veya uzun bir süre tek bir yere odaklanmak çeşitli duygu durumlarını temsil edilebiliyor. Dolayısıyla bireyin o uyaranla ilgilendiği veya işte bilinç düzeyinde ona karşı bir şey hissettiğini, bir duygu hissettiğini bize ifade edebiliyor. Yine göz izleme tekniğiyle bakışın yönü ve süresiyle göz bebeğindeki değişiklikler de tespit edilebiliyor. Göz izleme, bilişsel tepkileri ölçmek ve diğer yöntemlerle birlikte kullanılmaya uygun bir teknik. Özellikle yüz kodlama, diğer bir ifadeyle yüz ifade analizi ve galvanik deri tepkisi tekniğiyle birlikte kullanıldığında bakışın odak noktasının yanı sıra duyusal verileri de elde etmek mümkün oluyor. Diğer bir biyometrik yöntem biraz önce bahsettiğimiz yüz ifade analizi. Yüz ifade analizi, insan duygularının yüz ifadelerindeki değişikliklerle ölçmek ve sınıflandırmak için yüzün anatomik bileşenlerini kullanan bir sistem. Bu analiz ile herhangi bir ürün veya içeriğe ilişkin duygusal uyarılmanın ölçülmesi mümkün oluyor. Paul Ekman'ın tanımladığı 7 temel duygu bu yöntemle ölçülebiliyor. Dolayısıyla araştırmaya katılan bireylerin uyaranlara karşı verdiği duygusal tepkileri elde edebiliyoruz. Peki neden biyometrik yöntemler diye sorduğunuzda, bu yöntemler bireylerin uyaranlara karşı verdiği otonom sempatik sistemine bağlı müdahalesiz fizyolojik tepkileri, diğer bir anlamda duyusal tepkileri ölçebiliyor. Ki duyusal analizlerde de biz bu tarz tepkileri ölçmeyi amaçladığımız için biyometrik yöntemlerde bize yine bu konuda katkı sağlıyor. Duyusal analizlerde elde edilen nicel verilerin biyometrik analizlerden elde edilen verilerle karşılaştırılması ve doğrulanması, duyusal analizin geçerliliğini ve kuvvetini artıracağı düşünülüyor. Örnek olarak verecek olursak 3 farklı gıda ürünü incelemesinde, ambalaj incelemesinde görsel olarak incelendiği bir duyusal analizi göz önünde bulundurursak, göz takip cihazının eş zamanlı olarak kullanılmasıyla panelistin seçimlerindeki nedenler anlamlı olarak belirlenebilir veya hatalı çeşitli deney faktörlerinden etkilenen ön yargı gibi durumlar tespit edilebiliyor. Burada öneri ve amaçlarımıza baktığımızda duyusal gıda analizi araştırmalarında verilen yanıtlarda katılımcılara ait tutarlılık ve veri setinin kayması gibi olasılıkların ortadan kaldırılması ve çalışmamızın disiplinler arası bir yaklaşım ile gıdalarda duyusal analiz süreçlerine biyometrik veri toplama tekniklerini dahil etmeyi amaçlıyoruz. Bu çalışma karma yöntem değerlenen biyometrik veri hasadı tekniğini araştırma sahasına sokmayı öneriyor. Böylelikle gıdaların duyusal analizi esnasında katılımcıların hem öznel hem duyusal yanıtları bulgulanabilecek hem de eş zamanlı olarak otonom sinir sistemine bağlı biyometrik uyanlarından veri toplanabilecektir. Gıdaların duyusal analiz çalışması esnasında göz takibi ve galvanik deri tepkisi tekniğiyle otonom biyometrik veri toplanması ilk hedef olarak göz önünde bulunduruluyor. Ve gerçekleştirecek filosa çalışmaları ile yaklaşımları ile ilerleyen dönemde biyometrik veri tekniklerini de kapsayan gıda ürünlerine yönelik duyusal analiz sahalarının kurulması amaçlanıyor. Bir sonraki çalışmalarda bu tekniği kullanarak bir saha araştırması yapmayı düşünüyoruz. Umarım bunların sonuçlarını da sizlerle paylaşma şansı buluruz. Teşekkür ediyoruz bizi dinlediğiniz için.
You can send your questions to the authors about the presentation and the content from the email addresses we shared at the beginning of the presentation or from the live broadcast chat section. Questions sent through the chat section will be sent to the authors and will be answered by the authors.
Sunum ve içerik ile ilgili bildiri yazarlarına sorularınızı sunum başında paylaştığımız e-mail adreslerinden veya canlı yayın sohbet bölümünden iletebilirsiniz. Sohbet bölümünden iletilen sorular yazarlara ulaştırılarak cevaplanması sağlanacaktır.
Now, we will watch the presentation titled Using a Frequency Method to Detection Faults of Ball Bearing and Wind Systems created by Fatima Zora Charid, Horia Salih, Chaban Jabali, Abdinur Suali, Hamu Nouri.
Şimdi, Fatima Zohra Çerrat, Hoyriya Salhi, Çaban Dijibali, Abde Nur Soğuli, Hamun Nuri tarafından oluşturulmuş rüzgar sistemlerinde bilyalı Rulman hatalarını tespit etmek için bir frekans yöntemi kullanmak başlıklı bildirinin sunumunu izleyeceğiz. Buyurun sayın katılımcı.
Mr. the President of the session, Honorable Assistant, hello, thank you for accepting my article entitled Using the High Frequency Method to Detection Float of the Ball Bearing in Wind System. To do this, you have drawn the following work planning introduction, wind turbine, angular contact by bearing, dynamic model of rolling element bearing, the various defects of the bearing diagnostic techniques, result and discussion conclusion. A modern wind turbine typical has the three-blade rotor spinning about the rotor hub, which is coupled to the generator rotor shaft. The shaft can be mechanically connected through a gearbox or direct coupling. The rotor hub is connected to the enclosure called the nacelle. The nacelle house is gearbox, if present, generator, power, electrical converter, and control system. The turbine rotor and the nacelle are mounted on the turbine tower, but a big problem always present in the exploitation of wind energy in the mechanical part. The wind turbine experience mechanical vibration and electrical fluctuation that are not completely damped. The speed of the air flow around the wind turbine causes the minimization of the reliability of the various mechanical parts. The main found mode in the different mechanical parts of it. For example, they bring the speed increasing electric motor, the blade, among the big problem in wind power system are float in the bearing. A bearing is the mechanical element which is interposed between two parts of the machine, one of which is rotating and the other is fixed. The wind turbine experience mechanical vibration and electrical fluctuation that are not completely damped. The speed of the airflow around the wind turbine causes the minimization of the reliability of the various mechanical parts. The main flow mode in the different mechanical parts, for example, the bearing, the speed increase in electrical motor, the blade. This figure presents the wind turbine. Angular contact by bearing. A bearing is the mechanical element which is interposed between two parts of the machine, one of which is rotating and the other fixed. Today, the bearing take on more elaborate and varied form, and their use in rotating machine is becoming an obsolete necessity. Some of the big problem which wind power system are bearing flaws. They figure present le ball bearing. Dynamic modeling of the roller element bearing. For the ball bearing, you have adopted the model shown is figure. They about function Ft is given by the following experience present by this equation by application of the fundamental how dynamic. You have the different equation which governing the evaluation of the position x present by this equation. K present system static gain WN present own outputted please Z present damping factor. This figure present simplified model of the Rho element. Characteristic equation of the different equation is given by this question. So you have the following case: Z superior 1 present by this figure, which T1 T2 present by this equation. CZ inferior 1 present by this equation. CZ inferior A present by this equation. The various defects of the ball bearing, the various defects that can be observed on the bearing are manifested by the appearance of the periodic stock and specific frequency. This figure presents the different defects of the ball bearing, the defects on the ball, on the cage, on the other range, on the inner bearing diagnosis techniques. Among the technique currently available for the bearing diagnosis, envelope analysis is the most common and relatively well established, with unable to detect the float with location by matching the frequency spectrum of the envelope to the float frequency. Diagnostic focus on detecting the float, isolating the location and defining their severity based on the extract factor by the why the bearing signal is usually made by the result ones and those coming for other compound which showed by filtered out as the first. To make an effective progress from a certain spectrum, it is forever possible to use a certain number of the characteristic frequency or float frequency, which are following: characteristic frequency of the inner range, characteristic frequency of the other range, characteristic frequency of the cage, characteristic frequency of the ball, and these by the question. This result presents the frequency as function of the contact bearing. They test accorded on the during the student and progress show the influence of the contact angle on the mechanical bearing. To avoid that float frequency as function of the contact angle, we concluded that each time of the contact angle increases, the defect frequency will, and this result present frequency as function of the rotational frequency. The test occurred out during the student is progress show the influence of the bearing rotating frequency on the bearing behavior if the rotating frequency increases higher than the rotating frequency, which make it during the being in the normally state. Therefore, the float frequency increases for each change of the contact angle or rotation frequency. This effect of a rolling ball more than is will defect the wind energy for many advantages, which explain why it's one of the fastest growing energy source in the world. Research offer are aimed at addressing the challenges to great use of the wind bearing are among the most important component in wind power system. Statistical studies show that flower attributable of today bearing represents between 50% and 40% and 50% of the malfunction affecting the viability and that of the system. Surrounding frequency analysis is the most commonly used method of the analyzing high vibration signal. The most positive of the frequency analysis is the FFT or fast Fourier transform, which converts a signal from the time domain onto the frequency domain. Thank you for your attention.
You can send your questions to the authors about the presentation and the content from the email addresses we shared at the beginning of the presentation or from the live broadcast chat section. Questions sent through the chat section will be sent to the authors and will be answered by the authors.
Sunum ve içerik ile ilgili bildiri yazarlarına sorularınızı sunum başında paylaştığımız e-mail adreslerinden veya canlı yayın sohbet bölümünden iletebilirsiniz. Sohbet bölümünden iletilen sorular yazarlara ulaştırılarak cevaplanması sağlanacaktır.
Now, we will watch the presentation titled Serbian Tourism Management and Planning, using new business technologies created by Biljana Stojan Ilić, Gordana Petardugić.
Şimdi, Biljana Stojan Ilić ve Gordana Petardugić tarafından oluşturulmuş Sırbistan Turizm Yönetimi ve Planlaması Yeni İş Teknolojilerini Kullanma başlıklı bildirinin sunumunu izleyeceğiz. Buyurun sayın katılımcı.
Ladies and gentlemen, dear professors, I would like to greet you all from Serbia. My name is Biljana Ilić and I'm an associate professor at the Megatron University of Belgrade, Video of Business and Management. I wrote a paper titled Serbian Tourism Management and Planning Using New Business Technologies in collaboration with my colleague Gordana Đukić, a researcher at the Faculty of Economics at Belgrade. First of all, I want to thank to the organizer and Mr. Roman Aydin for this opportunity as well as for the invitation to participate in the Izmir conference. Now, I would like you to tell you more about the subject of my paper. Based on the global, turbulent environment, tourism should continuously collect new creative ideas in order to meet the needs of different consumers of tourism products. The paper presents the use of new technologies, but also the comparison of Serbia with some developed countries like in Europe, like Switzerland and Norway, in terms of the use of information technology. Nowadays, we are all witnessing on a global level the great roles that new technologies play in all spheres of human society. New technologies and their application in tourism are becoming the driving force of modern tourism industry. For the development of tourism in Serbia, it is necessary to mention the drafting of the new tourism development strategy for the period from 2016 to 2025, which contains numerous analyses of the current state and current level of tourism development in Serbia. The objectives of the strategy include sustainable economic, environmental, and social development of tourism, strengthening the competitiveness of the tourism industry and related activities in the domestic and international markets, increasing direct and total participation of the tourism sector in gross domestic product, EA and GDP, and in the structure of the total number of employees. How much and where is Serbia when the growth and development of tourism are in focus remains to be assessed by looking at certain situations. The guidelines based on the analysis of Serbian tourism could indicate the possibility in many ways of Serbia's progress towards sustainable tourism business. It is necessary to say that at the global level in the tourism sector, new trends in business are evident and more pronounced. In the field of promotion and reservations, new communication and promotional tools have been developed. They are based on e-marketing technology for communication with consumers, greatly increasing the efficiency of marketing activities. Sharing economy and virtual across-sector platform for providing information, communication between consumers according to the peer-to-peer model are becoming a feature of the new situation in the tourism business. Also, in accordance with the recommendations of the World Tourism Organization, it is necessary that e-marketing technology for communication with consumers be accessible to people with disabilities. Today's online distribution network, mobile smartphones, tablets, and other portable mobile devices have a crucial impact on travel decisions. Consumers have access to a lot of information when there is no mechanism of influence, but it is very important to constantly be present on the social media and monitoring the reaction of consumers. The revolution in the placement of promotional messages is brought about by 3D technology by stimulating experience in emotions. The ICT technology and social media provide special opportunities for developing countries to keep pace with modern trends and operate more efficiently in the market without the use of large financial resources. E-tourism has grown into a new paradigm called smart tourism. Because smart tourism is based on the use of Industry 4.0 technologies, which contains of Internet of Things, artificial intelligence, sensor use, cognitive technologies, and similar stuff, it is often called Tourism 4.0. Technological innovation within Industry 4.0, although of great importance to sectoral applications in tourism and hospitality, due to their complexity are often not recognized by businessmen and companies in tourism and hospitality in many countries. I would like to tell you some more about the Travel and Tourism Competitiveness Index. The Travel and Tourism Competitiveness Index, TTCI, is an indicator of the level of the national economy that contains factors that are important for the sustainable development of tourism because they contribute to the competitiveness of each country. TTCI consists of 4 sub-indices. First, enabling environment with 5 pillars. Second, TNT policy and enabling conditions with 4 pillars. Third, infrastructure with 3 pillars. And fourth, natural and cultural resources with 2 pillars, plus 90 individual indicators which are within different pillars. ICT readiness is the 5th pillar of the enabling environment sub-index. The ICT index is an indicator of the existing capacity of companies and individuals to provide tourists online services. The higher level of ICT readiness shows that there is a greater willingness to use the internet in tourism companies. When ICT readiness is higher, then the digital infrastructure logically is more developed and the quality of digital tourism services in companies is higher. The comparative components of the TTCI of Switzerland, Norway, and Serbia are shown in the table, but I would like to discuss it. Switzerland achieved a high rank of TTCI, 10 with score 5.0, and has high competitiveness and ranks best in relation to Serbia and Norway. Ranks compared with Serbia and Norway, although it had a decline in the overall results in the period from 2070 to 2090 by 4 places. It had high performance in terms of environmental sustainability, the first, human resources and labor market, the second, and business environment, third. It uses a high level of ICT in the business environment and innovations and interactions with tourists. However, digital technologies are less represented when the point is on the communicating with citizens. Switzerland should be paid special attention to price competitiveness where it has a very unfavorable result, then on natural resources and on cultural resources and business travel. Norway is one of the most competitive European TNT economies with a TTCI rank of 20 and score 6.3, although it had a decline too in the overall result in the period from 2070 to 2090 for 2 places from 80 to 20. It achieved good results in terms of infrastructure and ICT readiness and also in air transport. Norway lags behind Switzerland by 3 places in terms of the use of ICT technology in tourism. However, Norway should improve the performance of natural resources, digital tourism, and the business environment. Where is Serbia? Serbia achieved the biggest improvement in TTCI in Europe because it advanced by 12 places in the period from 2070 to 2090 and reached 83rd place in the world, although Serbia lags behind Switzerland, which is on the 10th place, and behind Norway, which is on 20th place, out of 140 observed countries. Serbia's policy was focused on the development of the tourism industry TNT and provided more favorable conditions in terms of visas, airfare, and airport taxes, and thus the openness of the country and reduced costs which affected the arrival of tourists. Despite the improvement in the performance of the business environment and the human resource market, Serbia should become more competitive. This is possible if it develops its cultural and national resources and increases the attractiveness of its national country brand. Also, it is necessary to increase the level of ICT readiness for Serbia. In terms of ICT, Serbia lags behind Switzerland by 51 and behind Norway by 48 places. So, the conclusion. Based on the context of current economic developments in the global market, geostrategic position, and open process of Serbia's accession to the European Union, current situation and development potential of tourism and hospitality and related activities, it is necessary for the government of Serbia to establish a new medium and long-term tourism mission, commitments such as measures for the development of energy, industry, agriculture, and especially the introduction of new information technologies. This is extremely important for overall domestic economic growth if we keep in mind that tourism and hospitality in the current global financial and economic crisis have shown the highest rate of recovery and global growth. So thank you for your attention. I wish you a good day and a good work on this conference.
You can send your questions to the authors about the presentation and the content from the email addresses we shared at the beginning of the presentation or from the live broadcast chat section. Questions sent through the chat section will be sent to the authors and will be answered by the authors.
Sunum ve içerik ile ilgili bildiri yazarlarına sorularınızı sunum başında paylaştığımız e-mail adreslerinden veya canlı yayın sohbet bölümünden iletebilirsiniz. Sohbet bölümünden iletilen sorular yazarlara ulaştırılarak cevaplanması sağlanacaktır.